Hi everyone. So this video has a brief discussion. We will briefly discuss two regularization techniques, which are basically semi-supervised learning and multitask learning. So let's first define them, and then we will mention why are we discussing them in the same video. So semi-supervised learning refers to the setting where you have a lot of unlabeled data and few labeled data, right? So let's say it's a classification task. I'm not only giving you, let's say it's images of digits. I'm not only giving you images with labels. I'm giving you a lot more images that don't have labels, right? And the hope is that the amount of unlabeled data can give the network an insight about the structure of the problem, right? About the structure of the data set itself, regardless of the classification task, so that it can efficiently process the labeled data, right? So for example, it could cluster the points in different clusters, right? And then once you give me the labels or the few labeled data, then I need only few within each cluster, right? So maybe I'm given points like that and like that, right? And then I decide to cluster them in 4 clusters, and then I need only few labeled data in each cluster so that I can generalize that this cluster has this label, that cluster has that label, and so on, right? So this is semi-supervised learning. Multitask learning refers to using the same network or the same model, the same neural network for carrying out multiple tasks, right? So maybe the same neural network is processing images, let's say for agriculture, for example. So it can process images. The same network can tell you whether what's the type of the plant, whether the plant has a disease or not, and maybe other interesting information, right? Let's say it's analyzing a scene, image of a scene, outdoor scene. So it can tell you maybe how many humans are in this image, and what are the identities of each of the persons in the image, right? So this is multitask learning. Now, multitask learning can happen in a variety of ways. Maybe the output neurons can classify multiple, can tell you information. Maybe I have multiple categories of output neurons, each for each task. And maybe a hidden layer is actually outputting a certain task, right? So maybe a hidden layer in the network is learning or is being penalized by, so the cost function is applied at the hidden neurons at one hidden layer, such that you are putting pressure on the network that this hidden layer should learn some kind of information, right? And this could be used as a kind of hierarchical learning, right? Because maybe I have more higher level abstractions that are classified or learned within the hidden layers, and then the more fine-tuned features are learned at the output layer, right? So why are we discussing them in the same topic? Because both of them puts pressure on the network to do what's called generative training, right? So far we have only discussed in classification problems, and the same concept applies even in regression, what's called discriminative training, right? Which is you're trying to learn features relevant to the task at hand, right? So you're trying to put pressure on the network to learn a certain task. Generative training means that you're learning the representation of the data. So the network, regardless of the classification or the regression task, the network wants to learn how to best represent the data, right? So in semi-supervised learning, this is clear from the unlabeled data. You want to learn the representation, and then this representation will hopefully help you in discriminating between the different classes. As we said in a simple example, the clustering thing, where if you form the cluster, maybe you learn to efficiently process the labeled data such that you generalize what you learn in one cluster to the rest of the cluster. Now, multitask learning can also be thought of as a way of generative training, because when the same model is learning multiple tasks, that puts pressure on that model to efficiently represent this data, right? And this is a less direct application of generative training, but it's actually the same concept. And we will see also in the next section that variants of this multitask learning can be used in optimizing deep neural networks to find efficient representation. So we will again have a discussion on this when discussing optimization algorithms. And the reason it will appear in optimization algorithms is that this representation can facilitate the training process, right? Because I could reduce overfitting, and then I could have a more stable optimization of actually fitting to the training, better generalizing, and at the same time facilitating the conversions of the training algorithm, right? So learning representations or generative training is actually a very important topic in machine learning in general, and nowadays there is a lot of hot open discussions about the potential of learning representations and incorporating it for better generalization to never seen before examples while training. Thank you.